Find the solution of the given initial value problem. So we have second order homogeneous constant coefficient ODE. So we find the general solution, and second order means we'll have two solutions and their linear combination. C1 first solution plus C2 second solution will be the general solution, and there will be two unknown constants, and we find them using these initial values. Okay, y at 0 equals 2 and y prime at 0 equals 1. So let's consider this differential equation, and for this we find the characteristic equation. So the characteristic equation is there's 1r squared plus 1r minus 2 equals 0. Let's solve for r. Factor this trinomial r plus 2r minus 1 equals 0. So r equals negative 2 and 1. That means e raised to negative 2t is one solution and e raised to 1t is another solution. Then their Wronskian is non-zero. They form a fundamental set of solutions, and the general solution will be then y equals C1 first solution plus C2 second solution. Now, using the given initial conditions, we need to determine the values of C1 and C2. Look at the second initial condition. We have y prime, so let's find the derivative of this. Okay, so at the end, once we find the C1 and C2, we come back here and write down the final answer. Okay, let's find the derivative to make use of the second initial condition. So derivative of exponential function is itself times the top, that's negative 2. So negative 2c1 e negative 2t plus et is just et, c2 et. So let's use the first initial condition using y at 0 equals 2. That's in the first equation. So y value is 2 when t is 0. So this is 2 equals c1 times e raised to negative 2 times 0, 0, e raised to 0, which is 1. So c1 plus c2, e0 is also 1. c1 plus c2, and using the second initial condition, which is y prime 0 equals 1. So here in the second row, so y prime is 1 when t is 0. So e0 is 1, so negative 2c1 plus c2 e raised to 0 is 1 c2. Okay, now we have a system of two linear equations in c1 and c2. We solve this system to find c1 and c2, and go back here in star and write down the final answer. So c2 here is negative 2c1. Let's multiply. You can use the method of elimination or substitution, it's up to you. If you multiply by 2, then 2c1 2c2, 2 times 2 4, then add these two, cancel, we get 2c2 plus c2, 3c2 equals 4 plus 1 5, divide by 3, so c2 equals 5/3. Okay, and we had c1 plus c2 equals 2, c1 plus c2 equals 2. Let's plug in the value of c2 and find c1. So c1 equals 2 minus c2. c2 happens to be 5/3. 2 is same as 6/3, right? 6 over 3. 6/3 minus 5/3, 1/3. So c1 is 1/3, c2 is 5/3. So we now go back, this is c1, and go to the star here and write down the final answer. Okay, so thus yt is c1, that's 1/3 e raised to negative 2t plus c2, which is 5/3 e raised to t. It's final.